So basically what I'm going to be showing is we've done an integration with Microsoft Lync. Where's the mic?
Yep. Just got to point it towards your face.
There we go. Using our One Fabric Connect. So our One Fabric Connect is our API that sits on top of NetSite. We've done a lot of third-party integrations with that, and the latest one is Microsoft Lync. So Microsoft Lync came out with a SDN API that they called. It's an API to expose more information about calls, the actual traffic, and also quality of service information. And that can be pushed out to third-party applications, which we've integrated with NetSite. One of the reasons they did that is, especially for quality of service, it's difficult to implement quality of service on a Microsoft Lync infrastructure because it uses such a wide range of ports. They're dynamic. And now with the Microsoft Lync application being used on iPads and laptops, you're not strictly now have voice on a voice VLAN. Now you're really, doing voice, video, and data on a single VLAN or wireless SSID. So because it uses that wide range of ports, if you would statically configure that on the network, you might be provisioning or prioritizing other application data. So what happens with Lync is as soon as there's a call made, it communicates that to NetSite, and then NetSite has information about the network, about the devices that are on the network. So it'll go down and dynamically provision the network for quality of service. After the call ends, it will then tear down that policy, and then we receive reporting information from Microsoft Lync, including quality of service information, a MOS score. And so we've created some reporting on that so you could see what kind of quality and the calls that you're having on the network. And that's what I'm going to show you here. And I'm going to show you again, this is part of OneView. And we've added it here under VoIP. Is that a little hard to reach? I could maybe make it.
No, looks fine. Can you crank the font size up just a hair?
Yeah, that's what I was trying to.
2 hairs. Oh, there we go.
Is that better? Well, I'll just have to scroll back.
It's on the screen.
Yeah.
Oh, I love that.
So here's our previous calls. We were doing some test calls earlier. And each line item is a call. And we'll trigger both voice and video calls. We don't prioritize, when you share your desktop or anything like that. Right now, it's just voice and video. The type of information that we're getting here in this view, you see the overall MOS score for the call. You see the start and the end time of the call. You see the duration. You see who called who, so the from and the to. You see the IP address information, and this is the end client IP address information. So this is what we trigger the policy on. In this case, this top one, you see it's from a switch. It says from switch port, but that's actually an access point. This was a wireless caller calling a wired client, because you can see here it was a switch port 1.1. And then we also get the layer 4 information, and that's where we key the dynamic policy, right, for that call. And as you can see, that layer 4 port changes from call to call. And this third call, you see that there was also a video. So there's 2 streams to a Microsoft Lync call, a voice and a video. So we'll go and provision that policy on the network dynamically for both. Other information that you get, I scroll to the side. Again, you see, where the call was. Was it a Wi-Fi call, wired call? And then we also provide you information about the devices, what type of devices are on there. Right now we're doing DAC fingerprinting to get that information. Microsoft is about to expose in their API more information about the client, because basically it's an agent running on these devices, and they gather a lot of information about the device, right? What OS, memory, all this stuff, and they're going to expose that on their API later this year. Let me get into some of the reports. So here's a call distribution report. So in this graph, you see the distribution of calls by source type. So you could see what kind of devices are making Microsoft Lync calls on the network. But the more useful one here is the call quality. So you could see in this one view the overall call quality. Right? The green is a good call, the yellow is fair, the red is poor. We'll be defining these a little bit more what they define, but so here you can see that there's quite a bit of poor quality. This is because we've been doing testing. But you could see if you see a lot of red, you know that there's a problem. Now, in order to pinpoint the problem, you can go deeper and now look at per switch. So you see the number of calls, the number of good calls on a per switch basis, and the number of poor calls. So in this view, you can see if there's a specific switch where you're having a lot of poor calls, you can now go a little deeper and have some information on trying to troubleshoot why those calls.
Let's call them sortable.
What's that?
Are those sortable?
Sortable?
Yeah.
Yes. Also by access point, so on the wireless point, right? So if you start seeing a lot of bad calls on a specific access point or group of access points, you know that maybe there's a problem within that that environment. And then we also provide device type information. So if there might be problems with a specific device type, OS, maybe it's a device problem, right? A version that needs to be upgraded or something like that, or a driver problem or something like that if you're having a lot of problems with specific devices. And this report here will give you, it's not up and running yet, but it'll give you quality over specific time. So you can tell maybe consistently they're having problems on a specific time of day, maybe you're having external interference at a specific time of day, and then you can do a little bit more investigating. And so, this is the first release. We haven't officially released it, but we're developing more tools for like searching. If a particular user calls in, you'll be able to put in that user, bring up all their Lync calls, and see where they've made the call, what qualities they've had on those calls, and things like that. So it's just providing additional insight into Microsoft Lync calls. In addition, on our Purview analytics, we've added fingerprints for Purview traffic. So now we can see the visibility in our Purview solution on Lync calls as well. Any questions? Anything else on there?
Just another example to show what you can do when you combine intelligent systems with each other. So, for example, the call quality by access point, you will never get it. You will never get it from Microsoft alone because the clients obviously don't know where they are connected to. So we provide more context here and provide a streamlined troubleshooting process. And as many mentioned, bringing those things together with all of the things that you've seen before around user and location and wireless becomes a much more straightforward and streamlined troubleshooting process, management process, as well as obviously the ability to provide better QoS as we use dynamic policies to basically prioritize those sessions.
Yep. So, and we're the first vendor that have end-to-end wired and wireless for Microsoft Lync.
And certainly, like we talked about earlier, we certainly don't go to market and force our customers to buy all of our products, but there clearly is value for those that invest both wired and wireless. Again, it's not a forced situation for our customer. I know Lee was making the comment that a switch is a switch, but you can see in many ways that a switch isn't just a PoE enabled device, that there is certainly value that can come from access switching technologies to be able to put this together. And Lync is really a great example of, even here we're deploying some new wired handsets, some new wireless handsets. We're using Lync on our laptops, on our mobile devices. It truly is a wired wireless type application, which is why I think so many people like talking about Lync and talking about how difficult that problem is.
So can you show us, I'm assuming that when a Lync call is established, this is receiving info saying there's a Lync call, push down a QoS policy, because Lync uses so many crazy port ranges. You're saying this port to this port, put a QoS policy in place. Can you show us
what that looks like?
What that looks like, yeah.
Yeah, we can show.
Let's see.
Can you? I don't know whether you can SSH into the box from here. So again, keep in mind it's still under development, but
No.
but we should be able to show you how that looks like. The short answer is yes. Eventually.
Do you have PuTTY or something on here? Within a telnet client?
And if it's outside the scope of this, we can take it offline too. So.
No, we actually were going to show that as part of the demo, and actually, as it turns out, we're almost at the.
Write down this address.
Okay, so that doesn't work.
That doesn't work.
New image. Okay. Can you try it on yours so we may
Yeah,
get
see if
the
we
VGA
can,
thing going?
Actually, I could.
It's probably easier.
Yep.
Other question while we're kind of waiting is, do you guys see running into scaling limitations around, ACLs and service policies around that kind of stuff when I'm pushing down so many dynamic, per session?
Certainly, yeah.
Is it something you guys think the current hardware is capable of doing what you want, or is it something that we're going to see next generation hardware, bigger TCAM tables?
So there are multiple answers to that question. So obviously when we talk about an AP level implementation going forward, it's just software, so we don't care too much about that. On the hardware side, it depends what hardware you're using. So we have different hardware architectures in our portfolio. Some of them use merchant silicon, some use custom silicon. The custom silicon ones scale to a degree where what you just mentioned is not a problem at all. With merchant silicon, you need to become more efficient on how you program those. And there might be some limitations, but you have to keep in mind it's not only the hardware itself, you have to scale the control plane as well. And to be honest, the control plane scale can be a bigger challenge depending on what you're trying to achieve. So you need to manage those flows, garbage collection, tear them down, bring them up again, depending on how the flows go. If clients roam, you have a lot of activity reprogramming those flows. So from that perspective, there's more challenge in the control plane architecture than it is in the data plane architecture. And addressing those makes a difference. So that's a differentiation capability for us, managing that better than other people. Yeah.
On the wireless side, either AP or the compliance is we are basically software-based forwarding, and so for us it's mostly the memory and CPU power. Throwing on more CPU cores per the device is actually going to scale.
Well, that you raised you said something that keyed a question for me, which is, as you're talking about roaming from AP to AP, it's obviously a different story than you're roaming from APs on one switch versus APs on two different switches. And if you've got this dynamic ACL that's being pushed down to one switch during a call being pinned up, that's one thing. But as you're talking about roaming from APs on switch A to switch B, you're telling me that you can push that dynamic ACL to a switch in time for there to be no dropped audio on a call?
I'm telling you that we know that this is a challenge, and we have all the components in place to address it, but it needs to be addressed. Yeah.
This is exactly what we're thinking about, and what our teams are trying to solve. And again, looking at it from a Wi-Fi perspective, it's a totally different set of problems than what is in the data center. And our engineering teams are trying to solve problems in the data center at the same time. So we're looking at it network-wide, end-to-end, the applications that are being delivered, and how do you solve these problems, right? It's not.
And there are multiple solution strategies to that I can't disclose yet.
Yes.
So.
But that brings up another good point. Is when you talk about you being working really closely with Microsoft and having that Lync compatibility with Wi-Fi. Well, what are some of the things that Extreme is doing as a part to your competitors, on using my device here or an iPad and making that Lync call, or even on their notebook and roaming between access points on a video call? Because sometimes that's a struggle for certain vendors, is where trying to maintain that call quality and actually roaming between given floor. Yeah. And so I kind of want to know what Extreme's...
on the RF side, the onus is the best one.
Basically, as we said, our architecture handles today 16,000 users roaming from one AP to another AP with a policy. The dynamic flow, the push down, is not different as a static flow. It's just one additional flow which has to maintain per user. It's done by appliance. So the solution is there. We have the solution. The question is communication between the one fabric.
I'm going to make the call
currently, this is implemented only for the switches. It will be implemented with the wireless. And when it will be implemented with the wireless, the existing platform that we have will handle the problems with the roaming.
Right. Okay. Yeah, I was more of trying to get involved in like the, how are you making sure that that traffic is staying where it is.
We have to solve this today with the policy. This has to be solved anyhow with the static policy today. So today
you're not worrying about how long that client stays on to that AP before it roams, because what happens is a lot of times the client doesn't want to actually move off to the next AP. It wants to hang on, and so you want to. Because I know Microsoft is working with that, right, to make sure that they could, with certain vendors, to say, okay, we can roam properly with a video call.
So you should basically steer the client, you say.
Yes.
Okay, so there's different. This problem exists today, even with the static flows. If the client doesn't roam, when it doesn't sense on time that the quality or SNR is low to be able to sustain the quality call, then you need a method to push into the other one. Yes? That's your question.
Yeah, so you're helping with that.
No, we're not helping today.
Okay. So it's still based on the client. Okay.
Yeah.
All right, so real quick, you guys wanted to see the dynamic configuration. So before the call, I did a show conf ACL, and it returned nothing, right? So as soon as we made the call, then 2 access lists were created because the devices are on the same switch. So it shows a destination address, protocol UDP. Here's the ports that we get from Microsoft Lync. And we're putting it in QP6. We're also replacing the diff-cert code point. That's so the rest of your network can prioritize the call. So you just doesn't have to be an extreme network. On the edge currently, you need XOS switches. But then going out to the rest of the network or even into the wireless, right, you could key off diff-cert code point because we're coloring the link traffic. And then if we hang up, the call, and hopefully it goes in. Oh, there it is.
Here we go.
Right, so it cleans up the access list. Right, so again, it dynamically builds the policy, tears it down. In case for some reason there's some communication issue and it doesn't tear down the ACL, we do have a cleanup process that'll go in and occasionally clean up stale entries, just in case.